So today we are going to be reviewing exponents, radicals, and solving for a given variable. So some exponent rules that you may have forgotten. When you're multiplying, you want to add the exponents. So in this first example, I have exponent of 3 and exponent of 4. I add them together and I get 7. They do need to have the same base, so since they both have x as the base, it's fine to add it and make x to the 7th. When dividing, you want to subtract the exponents. So if x to the 10th over x squared, I subtract 10 minus 2 and I get 8. There is a typo on your paper. So if you could change the 5, x to the 5th right there, to an 8. When raising a power to a power, you want to multiply your exponents. So I have a x cubed raised to another 4th power. I multiply 3 times 4 and I get x to the 12th. When raising a product to a power, you want to distribute the exponent. So I have 5 and x inside the parentheses, so I distribute the 4 exponent to the 5 and to the x. When raising a term to the power of 0, it equals 1. So anything raised to the power of 0 is always 1. Finally, when raised to a negative exponent, you move across the fraction bar. So if you look at my example, a to the 10th is already a positive exponent, so it stays where it's at. The b to the negative 2, though, to get rid of the negative exponent, I move it down bottom, so now it's become a positive 2. Same with the c to the negative 3. To make it a positive 3, I move it up top, and now it is a positive 3. Radicals, some rules. When you're dividing, you can separate the radical. So I have radical 5 over 4. I can separate that to be radical 5 over radical 4. And then you can break down and find doubles. So 4 breaks down to 2 and 2. So on the bottom it's just 2. On the top, 5 has no doubles. So that would be my answer, square root of 5 over 2. When multiplying, you can separate the radicals. For example, square root of 75, I can separate that into square root of 25 times the square root of 3. So 25 times 3 is 75, so it's totally fine to do that. And the reason why that's useful is because square root of 25 is 5, and then I just bring down the radical 3. That makes it easier to solve. When writing a radical, you can use exponents. This is something that you're going to see a lot on the SAT. So this square root of 289, sometimes they're going to rewrite it as 289 to the 1/2 power. So where that comes from is the exponent on the inside of the 289 is 1. So if there's no exponent there, it's 1. And then it's a square root, and they don't put the 2 on the outside. Sometimes if it's a cube root, they will put the 3 on the outside. If it's a 4th root, they'll put a 4 on the outside. But if it's a square root, they won't put anything. So that's where the 2 comes from on the bottom. So you have to know how to go back and forth between those two things. And often it'll make a problem easier if you put it in exponential form. Finally, when a number is squared, the original number can be positive or negative, but the square root of a number can only be positive. So what I mean by that is if I have a squared equals 81, a could either be 9 or it could be negative 9, because 9 squared equals 81, and so does negative 9 squared. So negative 9 times negative 9 is also 81. However, the square root of 81 is only 9. It cannot be negative 9 as well. And we'll get into imaginary numbers in another video. When there's a radical in the denominator, you'll need to rationalize. So sometimes the problem will ask you not to have a radical in the denominator. And so in the example here, I have square root of x plus 1 on the bottom and 14 up top. So I have to get rid of the square root on the bottom. So what I do is I multiply the top and the bottom by that square root. So that would give me on the top 14 square root of x plus 1. I can't actually multiply 4 by anything because 14 by anything because the 14 is not under the radical. On the bottom, when you multiply the same square root together, just a refresher, it just comes out of the square root. So it's just x plus 1. If the radical in the bottom is part of a binomial, then multiply by the conjugate. So what that means is a binomial will be like 3 plus square root of 5. The conjugate is the same thing, but it changes the sign in the middle. So I'm going to show you what happens when you multiply conjugates together. I'm going to use the box method. So I put 3 plus radical 5 up top, 3 minus radical 5 down the side. And I'm going to multiply them together. So in that first box, I do 3 times 3, that's 9. The second box, I do 3 times the radical 5, that's 3 radical 5. The next one, I do 3 times negative radical 5, that gets me negative 3 radical 5. And the last one, I have the same radical multiplied together, so it comes out of the radical, and it'd be a negative because it's a negative times a positive. So when you multiply a conjugate together, 3 radical 5 and negative 3 radical 5, those would completely cancel. And then I would add the other diagonal, 9 and negative 5 equals 4. So when you multiply conjugates, the radical will always disappear. So the O and the I, when you FOIL, would cancel each other out when you multiply conjugates. Last is solving for a given variable. Don't get overwhelmed with the variety and confusing variables. So sometimes you'll see it and you'll get flustered because you see so many letters. And what you want to do is just treat those variables like numbers and solve it like you would solve any other equation. So let's look at our first example. What is the value of 3 to the 5th times 27 to the 3rd over 81 to the 3rd power? So you could use your calculator if you're allowed and just plug it on in. However, you cannot count on being able to use this because this could very well be in the no calculator section. So I'm going to show you how you could do this without a calculator, because there's no way I definitely want to do 3 to the 5th power and 27 to the 3rd power. That sounds terrible and it's going to take you way too long. So what you want to do is figure out how you could get everything to be the same base so that you could use those exponent rules that I showed you in the first table. So how I could do that is I'm going to keep 3 to the 5th the same, but that 27, what I'm going to do is I'm going to change that to have a base of 3. So 27 is actually the same thing as 3 to the 3rd power. 3 times 3 times 3 is 27. So that right there is 27, and it's still going to be raised to that 3rd power all over. So then I'm going to try to figure out what could I make 81 to be. So 81 actually is 3 to the 4th power. So 3 times 3 times 3 times 3 is 81, and still going to be raised. So I still have those exponents. I'm just changing the base number to something that has the same base of 3. So now that everything has this base of 3, I'm going to use my exponent rules. So power to power, I multiply them together. So that's actually 3 to the 9th. Same with on the bottom. I multiply those together, 3 to the 12th. Then, whenever you multiply things with the same base, you can add your exponents. So on the top, that's actually 3 to the 14th power. And then the last exponent rule is when I have the same base and they're divided, I subtract them. So I can actually do 14 minus 12. So that gets me 3 to the 2nd power. And now that you can definitely do in your head. 3 squared is 9, which is my answer. All right, my next one. Which expression is equivalent to, and I have this big gross thing. So for these, it's a pretty safe idea to work from the outside in. So I'm going to work from the exponents on the very outside, so that negative 3 is where I'm going to start. So I want to get rid of the negative exponent first. So this 2 right here, it is going to stay on the top of a fraction because that negative 3 exponent does not apply to it. To make it a positive 3 exponent, I'm going to move that entire parenthesis, because that's what that negative 3 applies to the bottom. That becomes a positive 3. So then what I'm going to do is I'm going to distribute that cube to everything on the inside. So negative 4 to the 3rd power, negative 4 times negative 4 times negative 4 is negative 64. I multiplied these 3 and the 3 together, so that's j to the 9th. And I'm also going to multiply the exponents of the k's together, so negative 12. So then I'm going to get rid of that negative exponent by moving that k to the negative 12 up top to join the 2. That makes it a positive 12. All over, still negative 64, j to the 9th. And then the last thing I can do is I can reduce those big numbers, the 2 and the negative 64. So that reduces to 1 over negative 32. I can't reduce the k and the j because they are different bases. So that is answer choice B. All right, which of the following represents, and then this big gross thing. So since these have different indexes, that's that small number outside of it, you can't actually reduce them. So if they were the same index, then you could reduce the x to the 10th and the x to the 5th and the y's, but you can't because they're different indexes. So what I'm going to do first with this is I'm going to change everything into fraction form. So I take my x, it's the inside number, so 10 over the outside, 6. Same with the y, 12 over 6. I'm going to do the same thing on the bottom. 5 over 3, 6 over 3. So now I'm going to have to get all the same denominator so that I can simplify this. So on the top, I noticed that I could get both of those to have the bottom of 3, the denominator of 3, if I just cut it in half. So this x could reduce to 5 over 3. The y could reduce to 6 over 3. And I understand that can reduce even further. But as far as simplifying, if you get them all the same base, it's going to be a lot easier. So now they all have 3 on the bottom. So that means, if you notice, I can subtract my exponents because I'm dividing. So I can take these and subtract them, which 5/3 minus 5/3 is x to the 0. I can do the same thing with the y's. 6 over 3 minus 6 over 3 is 0. And then the final exponent rule that we learned in the table is, well, not the final, last one of the exponent rules is that everything to the 0 power is 1. So A is my answer. Which of the following expressions is equivalent to that? So we have a binomial on the bottom, and so I need to get rid of that by multiplying by the conjugate. So the conjugate is the same thing, but I changed the sign in between. So it was a minus, and I changed it to a plus. So for this, I'm going to have to FOIL or use the box method for the top and the bottom. So I am going to do the top first. So I'm going to go off to the side, and I am going to make myself a box. 3 radical 72, 3 radical 72. I multiply, so 3 times 3 is 9. 3 times the square root of 72 is 3 square root of 72. Same over here. And the last box is the same radical multiplied together, so it comes out of the radical. And then I add diagonals. 9 plus 72 is 81. And then this diagonal will not cancel because they aren't conjugates, because it's the same sign, not opposite. So I actually have to add the outside. So I add the 3's on the outside, and that gets 6. And then you keep the inside the same. So that's the top of the fraction. I'm going to do the same thing with the bottom. This time, since they are conjugates, it should clean up and make a nice even number. The radicals are going to cancel. So 9 again. I already know that these are going to cancel, so you really don't even have to do that. And the last one would be negative 72 because you have a positive times a negative. I can add those together, and that gets me negative 63. So that is not an answer choice. So I'm going to have to simplify this so that I get something that is an answer choice. So I am going to break down 72 and find doubles. So 72 breaks down. You can break it down multiple ways, but I know that 8 times 9 equals 72, and then 9 goes to 3 and 3, which is a double. 8 is 2 and 4, 2 and 2, which is another double. So I have 81 plus, I'm going to have a double 3 and a double 2. So a 3 times a 2, which is a 6, times this 6 is 36. On the inside, I have this 2 left over. So this still isn't an answer choice. However, I can eliminate a few. I know that it won't be C because there's no radical in C. And D, there'd have to be a 1, and 81 over 63 is not going to result in 1. So it's either A or B. So I asked myself, well, how the heck did they get -7 on the bottom? And so I did a little problem solving, and I realized that if I divide that by 9, I would get -7. And so I'm just going to divide everything else also by 9, and that will determine which answer it is. So 81 divided by 9 gets you 9. 36 divided by 9 is 4. You keep the radical the same, and then -7 on the bottom. So that is answer choice A. Alright, last one. So honestly, when I see something like this, and then I see a bunch of answers that have V equals, I save some time by not reading the crap that they put in there, because it usually isn't going to mean anything when it's just has everything solved for V. So I'm just going to start off by solving this. So I put this over 1, and I'm going to cross multiply to get rid of the fractions first. So 1 times 1 would just give me 1 equals, and then there's this strange symbol. I'm just going to use like a Y, and then the radical. Alright, so then what I'm going to do is I'm going to move over this variable first. Trying to get V alone. So then I need to get rid of the radical. So how I get rid of that is I square both sides. So when you square the radical, then the stuff that's underneath the radical just drops down. When I square the other side, I have to square everything. So 1 square is just 1, and then square the variable. So then, again, keeping in mind, I'm trying to get V alone. I'm going to move over the 1. So I'm going to subtract over the 1. So I have 1 over y squared minus 1 equals, and then that negative has to stay, that minus that was before it. So that can't drop. It's going to make a difference if you drop it. I can get rid of that negative. I can make it a positive as long as I change the signs of everything on the other side. And I'm going to flip-flop that order. So really it's going to be 1 over y, or 1 minus 1 over y squared, equals b squared over c squared. So then I'm going to get rid of the c squared by multiplying everything by c squared. So I'm getting closer. And then the last thing, to get rid of the squared on top of the v, I need to square root. So square root that entire thing. So now I would have v equals, I can actually square root the c squared that's underneath there. So I'm going to bring a c on the outside, and everything else I leave underneath it. And that is answer choice D.